The growing usage of AI coding assistants is revealing one thing. Many of us have been writing code for years while doing very little software engineering. AI coding assistants are pushing us to a higher level of abstractions, which means revisiting software engineering. Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mozaic Works studios. And today I want to talk about my favorite James Bond, which is, of course, Pierce Brosnan. He was really fun. There were adventure movies. I had a lot of fun watching those, not those gritty recent ones, which I don't really understand. Oh, sorry. So we were talking about something else. Right. Last week I had a very interesting course with on AI-powered software engineering. And during the course, participants have had a lot of aha moments, but one of them was when one of the participants said, oh, so actually now, if you are using these coding assistants, you need to focus on process. And in my mind, this was like, well, we always had to focus on process because that's what software engineering is about, or it's also about this. And we had a longer conversation, but what I like to stress here is what is going on and what will happen if we increase the usage of AI coding assistants. First of all, let me define software engineering because this is a very important part of the story. To me, software engineering is solving problems, sometimes using code. The job was always about solving problems. And the example I like to give is, imagine you are one of the first people who are building a bridge. You don't know the physics, you cannot compute things, you don't have maths, you don't have formulas. You don't have an extended experience with it. Your problem is that you need to cross a river from one side to the other. So what do? Well, you apply some of the things that we usually do in engineering. You build a solution. You imagine a solution and build it. So for example, what could be such a solution? You could add some rocks in the river, and then you notice that when the water level rises, that's no longer a solution. Also, it's not very useful for people who are not very athletic. Another thing you could do is to cut a tree on one side of the river and make it fall down over the river. So now you have a tree that you can walk onto, and then maybe you can improve it, but by making it flatter and so on. And the key insight here is that you use a few techniques. You use prototyping, iterations, and feedback loops. These are the fundamental techniques that you use in engineering, and these are the fundamental techniques that we use in software engineering. In fact, this is what Agile has been about. It was not about daily scrums or a scrum master or a product owner. It has been about introducing feedback loops, iterations, and prototypes in the way we build things, because what we want to do is to solve a problem, sometimes using code, and this is what software engineering is about. And now if we go to using AI assistants and the next level of using AI agents and autonomous agentic workflows, you start seeing some cracks into this, because AI agents and AI assistants, they make mistakes. Some of the mistakes are hallucinations. Some are answers that are not good enough because they operate with a lower resolution of the problem. And if you are using those in a multi-step workflow, then mistakes compound. So if you start with a mistake from the beginning and you let an autonomous system go on, it will end up very far away from what you actually want. So mistakes compound unless caught early. The way you can deal with that is, of course, human in the loop. You can ask people to review things early and often, which is, again, very similar to Agile, in order to correct for those mistakes. But what if we were to move to the next step? Then we need to use systems thinking, because what you have is a system formed of agents and each agent can make its own mistakes, and the mistakes can compound. But there are ways of dealing with that come from systems thinking, and once again, those are iterations, feedback loops, boundaries. You can set boundaries on the outcome, for example, and if the outcome is very far from what you want, then go back to and iterate once again. Emergent behavior that you can monitor. You cannot really predict, but you can monitor and see whether it appears and where it takes you. Engineers who think in systems recognize the patterns. Feedback loops catch errors early, boundaries contain propagations, iterations allow correction, and emergent behaviors need monitoring. These are new ideas. This is just engineering. It's software engineering applied at a higher level of abstraction. In fact, I've learned about these things in university. I was interested in those and I kept reading about them. But when I really applied them in practice was when I was doing Agile coaching and helping with Agile transformation, because it's exactly this theory that we apply to the socio-technical system that is an Agile or an organization that follows agility. So self-correcting systems will require using these techniques plus asking people in the right places. And this is how you make meaningful and useful automations. And this leads us to our conclusion. AI didn't change what software engineering is. It just empowered more of us to amplify our skills as software engineers. And if you have any questions, any comments about that, please let me know. We love comments. Thank you kindly for the view. And until next time, remember to think, design, and work smart. See you next Saturday.